All right, so we're going to talk today about APRS, and this is the first session of our APRS deep dive. Now, how many people participated in our WinLink deep dives that we did the first half of the year? So we had a few people come out for those. The objective of these deep dives is to not just learn about something, but figure it out, understand it, and do it. And then hopefully you will retain that knowledge because you actually did something with it. So we're going to follow the same program with APRS. It's probably going to take a few months to go through this. It'll be the second Thursday classes of each month for the next few months. We'll be talking about APRS. Today, we're going to mainly just talk about what APRS is and how it works and that kind of stuff, what you will need to bring with you or to have in your possession to be able to play APRS. And we'll also do some demos. So, all right. And of course, you don't want to do what you're supposed to be doing. Let me drag this over here. Okay. There we go. So what is APRS? I've heard APRS stand for a lot of different things. Amateur position reporting system, amateur packet reporting system, automatic packet reporting system, automatic position reporting system. Does anybody know what the correct one is? The third one. Neil says it's the third one. That is correct. It is the automatic packet reporting system. All right. So let's break that down. Automatic. You don't have to have a control operator taking action to make it do something, okay? Packet, it's based on packet radio. Reporting, it's used for disseminating information. And system means it's not a standalone thing. This is actually multiple radios, multiple systems, computers, networks, all of this ties together to make this thing work, okay? So it's not just about position reporting. Now, when I first got my license and I was looking at amateur radios to buy, and I went to, you guys remember they used to call it the candy store, the local guy that sold amateur radio stuff, long gone at this point, but I went in there and I was talking to him about what radio I should get. And I was thinking I had two choices. One was they were both Kenwoods. One was the D7, which is an APRS capable radio, and the other was the F6. Which is not APRS capable, but is a tribander. And he said, oh, you don't want the D7. People will know where you are all the time. How do you do you want to explain why your car is parked outside the bar or whatever, and I'm like, okay, whatever, but I ended up buying the F6 and I don't regret that because that is a fabulous little radio. It's been out of manufacture for many years, but if you can get a hold of one, it is a delightful little tri-band radio, 2 meter, 1.25 meter, and 70 centimeter. Has wideband receive, 500 kilohertz to in the gigahertz range, and it's a great little radio. So APRS is not just about position reporting. It has the ability to report positions. It's not about position reporting. It has the ability to track vehicles. It's not about tracking vehicles. It has the ability to hook into the internet to spread your information over a wide area, but it's not about wide area usage. It is a tactical, real-time information distribution system. Okay, we're going to break that down. So, tactical. The idea is this should have local information that is useful and important to you where you happen to be right now, okay? It's real time. That information is current. It's not like 6 months old. Like if you go on a website that says where all of the Airden nodes are, Paul, yeah, that's where they were 2 years ago. Are any of those still up? Who knows, right? Same thing with like packet radio. There's a packet radio node finder thing. I couldn't find anything on that site that was newer than 2 years ago. Not super helpful. APRS is real time. It's what's happening right now. Information and system are the other keywords. An operator, the idea is an operator should be able to turn their radio on and within a half hour, be able to look at their radio and know who else is around, who they can talk to directly, what the local repeater is, if there's a net tonight, where it's at, that kind of information, right? You want the information to be tactical and relevant so that you have that information when you need it. All right. So tactical information. Where is something? Where is the fire station? Where is the repeater? Where is the lead bike in a bike ride? Where is the last bike in a bike ride, or the follow-up motorcycle rider? Where are they at in a bike ride? These are the kinds of things that you want to have reporting out on APRS. Where's the local ham fest? How do I get there? Where does the local ham radio club meet and when? Those are the kinds of things you want APRS for. What else can it do? It can do a lot of things, okay? You can do instant messaging. You know how you do text messaging with your phone? You can do text messaging on APRS without the internet. So I can send a message to somebody, assuming the radio is on. Whether they're looking at the radio or not, they can come back and read that message later. We'll do this in the demo. We'll talk about it. Station to station, either direct or through a digipeater. If you're not familiar with digipeters, we're going to talk about that some more later. There's also things like SMS gate and email gateways. So assuming the internet is up, but maybe you're not where you can reach the phone service, but you can reach a digipeater with your handheld, you can actually send a message through APRS that gets gatewayed into an email message and can be delivered to somebody. Okay, so that's kind of cool. We'll talk about that. SOTA and POTA spotting. So SOTA, summits on the air, POTA, parks on the air. Basically, you take your radios out to a mountaintop or a park and you set up and you try to make contacts. Well, if nobody knows you're there, it's hard to make contacts. So you need to be spotted at that location. APRS has the ability to automatically spot you because it knows where you are. You have your GPS on your radio and it says, oh, he's approached the summit. We should do a SOTA spot for him. And boom, there you are. Now you're out there. Whois will give you information about a call sign. WXBot will give you weather information that is live. That's kind of cool. Telemetry. Either a fixed station can be reporting telemetry. You might have a balloon or a rocket or a satellite that is reporting some kind of telemetry. That can be done over APRS. We'll look at some examples of that. It can do whatever you think you can make it do, okay? If you have an idea and nobody else has done that, there's nothing stopping you from implementing that. You're amateur radio operators. You're supposed to be experimentalists. You're supposed to play with things and try to understand things. There are libraries that help you write programs to tie into APRS. It's easy to tie into the global APRS network. Figure out what you want it to do, write some code, put that service out there, get it out there and let people do it. That's where SMS gate and the email gateway came from, was people saw a need to do something and they said, huh, I wonder if we can make that happen. And sure enough, they can. All right, so let's talk a little bit about the background history of APRS. APRS was originally developed by a gentleman named Bob Bruninga, KB4APR. Bob is Silent Key. He passed away February 7th of 2022 of cancer. But he was a faculty member at the U.S. Naval Academy in Annapolis. And he actually used to come out here to Utah routinely, at least once a year, for many years, because at Utah State University, they do this thing called the Small Satellite Conference. And Bob was heavily involved in small satellite design and deployment. And so he would come to that every year and he would do a APRS presentation on the latest state of APRS for the Cache Valley Ham Group, but the Bridgerland Club or whatever it is. Paul's nodding over there. So the original implementation of APRS software was on the Apple II. You guys remember the Apple II? This was a long time ago, right? Apple II had a 6502 processor. It had an 8-bit CPU in it. And I think it had, I don't know, 16K of RAM or something like that. And everything lived on floppy disks, right? So this stuff was designed back in the early days, right? What he took was he had this idea of, we have packet radio, but we don't have a good way to get tactical information out. And at the time, GPS was just starting to be, I don't want to say demilitarized, but if you look at the GPS system, the GPS system has two separate setups to deliver positional information. One band is only used by the military, and one band is only used by non-military entities. There was this thing called position ambiguity that was added to the non-military signal when GPS was first deployed. And so the closest you were going to get with your GPS receiver was probably within a half a mile or so.
50 yards or so.
No, it was much worse than that.
Yeah, well, I remember I parked my four-wheeler, and I'm like, it says it's right here.
Yeah, right.
And
Yeah.
I'm like,
It's around there somewhere. Yeah. No, in the early 80s, they turned that ambiguity off. And that's when you could get your GPS position down to within, 30 feet or so. And that was a great thing, because now people could start using it for navigation and stuff like that, which previously, yeah, you could use it to get a general idea of where you were, but it wasn't accurate enough to actually like figure out what road you were on and tell you which way to go to get somewhere. So when they turned that off, it spawned a whole bunch of things like geocaching, navigation devices in your car, the maps on your phone, all that kind of stuff happened because they turned off that ambiguity. Now, they do reserve the right to turn that ambiguity back on at any moment. But these days, there's 3 separate GPS like systems. There's GPS, there's GLONASS, and then there's a third one that I can't remember. And so most of your devices are smart enough to receive all 3 of those setups and be able to pick which one is giving the best signal. So we have this technology now, and Bob figured out, why don't we take advantage of GPS to get this positional information and use that to deliver a tactical picture to amateur radio operators out on the field, right? In fact, one of the original uses of APRS was whenever they would have the Army-Navy football game, they would move the football from wherever its starting location was to wherever the game was. And they put an APRS device on the football so they could track where the football was as it moved around to get to its location wherever the game was. So kind of a cool thing. Yes, and we will talk about specific hardware as well. So APRS uses packet radio technology, right? So there's 3 main components: some kind of display or interface, a TNC, a terminal node controller. It's essentially a modem, okay, and a radio. Now, the display or interface is typically a computer, a phone, a tablet, something of that nature, something that has a display on it that you can see. Maybe has a keyboard that you can interact with. The TNC, they actually have hardware TNCs. And we talked about this when we were talking about WinLink, because you have to have a TNC to play WinLink as well, right? So when anytime you're doing packet radio, you've got to have a TNC. And I see Bob waving around his MobiLink D. Is that what that is?
This is for MobiLink.
Yeah. That is a little TNC. I've got a picture of it on the slides. I'll show it in a sec. But basically what it does is it hooks up your display device, your computer, your tablet, whatever, to your radio. Okay. Typically these days, our TNCs are in software. We'll talk about that in a minute. The radio operates on VHF, on a standardized national frequency. Okay, all three components of an APRS station, the display, the TNC, and the radio, can be in the single box. Right here. The picture on the screen is a Kenwood, I think that's the 710. We have one of those over at the EOC. In fact, I think the fire department owns 3 of them, somebody said. 2 of them are not currently in use. Kenwood, Yaesu, and Anytone have all manufactured radios with some kind of APRS functionality built in. Some of them are more functional and capable than others, okay? I haven't seen or heard of any ICOM radios that have APRS built in. Anybody know of any ICOMs that have APRS?
No, just DPRS.
DPRS for D-Star, right? And we're not going to talk about DPRS, but just briefly, DPRS is a digital version of APRS, and it is gatewayed into the APRS system, okay? DMR radios also have this functionality. And so I didn't bring my Anytone, but my Anytone 878 will do APRS over digital over the DMR radio, but it won't do it over analog. The newer version of the 878, the Plus, will do it over analog, but I don't have that radio. So, all right. Here's a couple other examples. This one is the Pico APRS. That one. This is a gadget. It's literally will fit in your hand, and it has the transceiver, the TNC, and the display all built into this unit. It also costs a lot of money. I've only seen one in the wild, and it was in the jersey pocket of a bike rider at the Bike MS a few years ago. He had one, and he showed it to me and said, "Look."
Anybody who came to date my daughter, I made him. All of that.
And then the other one that's shown here is an Yaesu FT2D, is another example of a radio with built-in APRS functionality. Okay. So, and then this last one shows the Moby Link D, like Bob has over here. Basically, what this is it's a little box that connects to your radio with a little cable, and then it has Bluetooth in it, and it connects to your phone or your tablet or your computer through Bluetooth. So that's kind of cool. It is a full KISS TNC. So when we talk about TNCs, there's a full TNC, which has capabilities of its own. It has a language you can command it and do things. And then you have KISS, which stands for Keep It Simple Stupid. Basically what they did was they abstracted out all of the command structures of the TNC onto the computer side and only kept the modem and radio communications side. And so there's a very simple protocol for the computer to communicate with a KISS TNC into the radio. Let's see. What I've got showing here is an application called APRS Droid, which runs on Android and is an APRS client that works great with the Mobile Link D that like Bob has over there. And I don't know, some people just say Moby Link, but there is a D on the end of Moby Link. And so I always say Moby Link D. I don't know what the correct pronunciation of that is. I'd have to ask the guy who built it, but they're up to version 4 of that device now. So the early versions, the one I have is a version 2, and it didn't work with Apple devices. But the version 3 and the version 4 work with Apple devices.
All the ham YouTubers call it Moby Linked.
Moby Linked?
Like past tense. Yeah,
Yeah.
you've been Moby Linked.
Well,
I don't know if that's correct, but that's what I see them.
they're wrong, but you know, they're wrong, but we won't hold it against them. So anyway, I always call it Moby Link D. So all right, so how does it work? You can also use a software modem. So you mentioned, will this work with my Signal Link? Yes, it will. Just like you use your Signal Link with WinLink to a sound modem of some kind to connect to your computer to your radio, same thing will work with APRS. Okay. There's a couple of different sound modems. Direwolf, sound modem. There's another one, I can't remember the name of it. It's named after some dude's call sign that starts with a U, I think. UZ something, I can't remember. Paul, you look like you might know what I'm talking about. You're trying to remember it as well, yeah. Yeah, so the basic idea is this is software that runs on your computer that pretends to be a TNC to other software that's running on your computer and uses some kind of audio device which is connected to your radio. And the typical ones are the Signal Link or the DigiRig. I know Jeff has a DigiRig. I've got a Signal Link in the box here. I can pull it out and show it to you guys later if you want to see it. But that basically handles the TNC side of the picture. Half of it in software running on your computer, half of it in hardware is the physical interface to the radio. I've seen people directly plug their speaker and mic ports on the radio into their computer's audio jack. I don't recommend doing that because there's no isolation if you do that.
It also requires using Vox, which.
And you have to use Vox on the radio. You have to set the radio for Vox because there's no PTT control that way. Systems like the DigiRig and SignalLink is kind of weird that way because you tell your software that it's using Vox, but it's not really using Vox on the radio side. The SignalLink emulates Vox for keying up the radio, and it actually has a physical cable that keys up your radio and unkeys. DigiRig also physically keys and unkeys your radio, so it depends on that functionality. So let's see. You'd run the APRS software on your computer, and I list a couple of examples here, a few examples. YAC stands for yet another APRS client. APRS ISCE is another one, and Exaster is one that is a Linux or Unix APRS software. There's also another one that I can't remember the name of. It's something like PowerPoint or something like that. That's pretty new and looks pretty cool, but doesn't implement all of the functionality that that you would want to have in a full-scale APRS client. You don't need much else. If your radio has a data port on it, when it says it's a data port, it doesn't mean it's data. It means it's an actual audio connection on your radio. And typically it'll be one of these DIN type connectors of some kind. Different manufacturers use different ones, some with 6 pins, some with 8 pins, some with 10 pins. It depends on the radio, depends on the manufacturer. Just need to make sure you get the right cable from whoever made your sound modem device, your Signal Link or your DigiRig or whatever, to plug into that. The advantage of this over plugging into the keyboard and mouse port on the side of the radio, or keyboard and speaker port, not keyboard and mouse, keyboard and speaker port, is typically if you have this data port, it will be pre-discriminator audio. So it will, there's no squelch involved. You don't have to monkey with the squelch. It's always listening, and it's not, the audio is not adjusted for hopefully making voices sound better, because we're not talking about voices. We're talking about data bursts, right? If you want to know what it sounds like, do you guys remember the old 1200 baud modems? It sounds a lot like an old 1200 baud modem, which makes sense since it's running at 1200 baud on VHF. Up to 9600 baud on 70 centimeters. All right, let's move on. So how does it work? Like packet radio, stations have an ID and an SSID. So the ID is your call sign. The SSID is a numeric value from 0 to 15, which encodes into 3 bits, interestingly enough. Stations also have a symbol or icon associated with them that can represent visually what type of station it is. Maybe it's a symbol for a digipeater, for a hospital, a mobile radio, like a vehicle or something like that. The symbol I use on my D72 is a picture, a little icon of a dude running. And, or in my case, walking, but, yeah, so the symbol is kind of a quick visual representation that you'll see on the map. And if we go back to that picture here, you can kind of see there's like a little house. Oh, see that? There's like a little house here. There's WX, our weather stations. You'll see, let's see.
You got a repeater on there,
Is there a repeater on there?
right there by.
Right here, like a little antenna tower, that indicates the repeater. This is like in Berlin, where this picture was taken. The guy who wrote APRS Droid is German, so of course his sample picture is gonna be in Germany. Okay. So, let's see, where were we? It uses AX25 protocol that packet radio uses, but it uses what's called UI mode packets. UI is unnumbered information packets, okay? So when you're doing packet radio, you have a source station ID and a destination station ID, and you send packets from one to the other. And if you're going through a digipeater, you maybe have a path of stations that are in sequence that you have to route through. So you send it to the first one, he sends it to the next one, he sends it to the next one. Those are all station IDs based on the call sign of the station owner. And they also do numbering of those packets so that you know if that packet made it through or not. You get acknowledgements and things like that. APRS doesn't depend on that, okay? It's kind of a flood fill algorithm. You're basically sending this packet out into the wild and everybody's going to receive it, okay?
255 packet.
Like a broadcast packet in the network world. It's connectionless. You don't specify the recipient. The recipient address in the packet, because remember, we're using a packet radio protocol, so it still has to look like a packet radio packet, but the recipient address in the packet is replaced with a keyword that identifies typically the type of equipment. And there's a huge list of different APRS software and hardware devices that can be specified there. Typically, you don't have to worry about that. The software you're using will use whatever it's used to, and you don't really care so much. We'll look at, when we go to the demo, we'll look at some examples of what some of those look like. All right, let's go a little deeper. So it's a packet radio protocol. It encodes data into packets, which are concise, small chunks of data. And then those are transmitted on the air and received by other stations. APRS is all one to many. It uses this kind of flood fill algorithm for distributing those packets. So it's not like I'm going to send an APRS packet and only Neil is going to receive it. Everyone will see it. Okay. Everyone will receive it and look at it, be able to look at it. Packets are digipeated generically using aliases. We'll talk about the path aliases in a minute here. So you don't have to know the underlying network topology when you're playing APRS like you do with packet radio. If I want to send a packet to somebody in Ogden, for example, on packet radio, I have to know the intervening stations my packet has to go through to get to him and get back. There are some modifications of packet that you don't necessarily have to do that, where the routing information is automatically determined. But in general, you would have to know that. With APRS, all I do is say, hey, packet, go through 2 digipeaters and talk to everybody you can see in that range. Okay. All right. Digipeating is used to reduce the required bandwidth and to prevent network flooding. I say that to a certain extent. Basically, if a digipeater hears your packet and it's already heard it, it's not going to send it again. Okay, so it's going to try not to flood the network. So if I send a packet and it's digipeated by digipeater A and digipeater B receives my packet and the packet that came from digipeater A, it's not going to resend it. Okay, it'll resend the one I sent, but it won't resend the one that digipeater A sent. So we'll talk more about digipeating, and I've got a visual example coming up here. It uses these UI frames in connectionless mode, and the physical layer uses AFSK encoding of data, typically at 1200 baud. AFSK is frequency shift keying. So there's two tones that are mixed together, and it encodes the bits by changing those tones. And so typically what you'll hear on the radio is you'll hear something that sounds like, and that's the actual data that's being transmitted. All right. There are nationally defined common frequencies set aside for APRS. And these are well-defined and known. So if you're traveling somewhere and you want to take your APRS radio, you can do that if the laws of the country you're traveling to allow you to do that, right? Anywhere in North America, we're going to be using 144.39 on 2 meter band. In Europe and some of Asia, I hesitate to say most of Asia, but a lot of Asia and a lot of Africa, it's 144.80. China is 144.64. Australia is 145.175, and so on. So you have an idea based on where you're going, how to configure your radio, what frequency you want to set your radio up on. If you're here in the US or Canada or Mexico, always 144.39. Okay. That is good and it's bad, right? And we'll talk more about why in a minute. So APRS revolves around two basic concepts. There's messages, which can be both one-way and two-way messaging, and there's objects, which can be things like stations, temporary objects, anything like that. One of the big factors in APRS is the decay or limited lifetime of objects and information. Remember, if it's not current, it's not useful. So if I publish a repeater object, I put a time on that if I don't refresh that object within that time, it will go away. Okay. It is possible to publish an object with an infinite lifetime. You can do that. And a lot of people do that for objects like repeaters and stuff. Nobody really owns these objects though, okay? And that's kind of an important point, because if I happen to be looking and I say, there's an object right there that I know is not there, I can send out a new object with that same name, and now I own it, and then I can delete it and it goes away. And nothing can stop me from doing that, right? So evil people don't play APRS. Only nice people play APRS. Remember, stale information isn't useful. APRS has a net cycle time of 10 minutes for local information. And by that, I mean direct stuff, things that you can hear directly. All stations should be beaconing on a 10-minute interval. For stations 2 hops away, it's a 20-minute cycle, and 3 hops away, it's a 30-minute cycle. That's why I say, if you turn your radio on and wait 30 minutes, you should have a tactical picture of what's going on wherever you are. Okay. All right. Let's see. APRS has this messaging functionality, right? Messages are not guaranteed to be delivered. Now, APRS will try to deliver them. Okay. So if I send a message to Neil, for example, and he doesn't acknowledge it, that he received it, my radio will try again several more times, usually for up to about 2 hours. It'll back off. So it's not like resending it every 10 minutes. It might send it the first time, and then it might send it in a minute if it didn't hear something, and then it might send it in 10 minutes, and then it might send it in a half hour. By the time 2 hours have gone by, it figures that message is no good anymore. So it's not going to try to resend it anymore after that.
It's a cross between a TCP packet and a UDP.
Kind of, yeah. It's like you can implement reliable delivery in a UDP packet, right? If I send you a UDP, so if you're not familiar with networking, there's 2 basic protocols that are used on the internet UDP, which is user datagram protocol, and TCP, which is what's a T stand for? I don't remember. It's a connected protocol, basically. The idea is if I open a TCP connection from my host to this other host, and I start sending data down that connection, I am guaranteed that the data will arrive at the other end in order, or I will know that it didn't make it and my connection will fail. Okay. With UDP, I'm just throwing packets out there. Maybe they get there, maybe they don't. Now, the guy who's receiving the packet could say, oh, I received a UDP packet from you. I will send you an acknowledgement packet back. And then I could possibly receive that, maybe not. And you get into this whole, do I act my acts or, APRS, if I'm sending a message, it will have a sequence number on it and it will be expecting to receive an acknowledgement that that message was received. So if I receive a message, my device will automatically acknowledge that by sending another packet back. If it doesn't get through, that guy's going to retry a few times until a couple hours go by. Okay. Let's see. Objects and items are the other thing. So that's messaging. Objects and items are the other thing, right? So objects include things that are stations and things that are not stations. So you can actually put objects out there and they'll automatically get distributed over the network. See you, Dave.
Was it something Jan said?
Yes, it was that Jan said it's 7:30.
You say,
So Dave will turn into a pumpkin at 8 o'clock, so he has to go home. So I can, as an operator, I can publish an object and it will automatically get sent out. Objects can have positional information. They can have course and speed information. They can have a timestamp or expiration date. They can carry additional information such as telemetry, weather, that kind of stuff. Objects can also be geometric shapes like lines, circles, things like that, polygons. You could theoretically, if you were motivated and you were doing a bike ride or something like that, you could publish objects that indicate the bike route, the route that the riders will be taking, which is kind of cool. Do people do that? Not usually, but it is possible to do that. Items are also like objects, but they don't have a timestamp, so they're not going to expire, right? Any operator can take over an object by sending a new one with the same name, or can destroy an object by sending the kill code for that name. Okay, so we hit that already. So let's look at the difference between objects and items. The typical distinguishing factor is that items are used for inanimate objects like checkpoints, aid stations, repeaters, things like that. Objects are used for moving items like stations, spacecraft, runners, things like that. Okay. APRS uses this kind of generic digipeating. Digipeters will accept aliases that they will digipete for, and they look at the path field of the packet to decide if they're going to digipete that or not. The paths contain information about how many hops you want your packet to go, and we use a paradigm which we call the new N paradigm, and it was new in 2004. So it's 20 years old, but we still call it the new N protocol, right? Or the new N paradigm. Previously, the targets that we used were things like relay, wide, and trace. We don't use those anymore. Occasionally, when you are out in the wild, you will encounter some old TNC that is sitting around somewhere still on the air, sending out things with a relay path. And when you see that, you can either ignore it or you can spend the time to try to contact whoever put it up, who may not exist anymore, and have them fix it, update it, or remove it. Sometimes that's worth doing. Sometimes that's not so worth doing. Everybody uses a path now that looks like wide n-n with some appropriate value for n. In general, if you think about what this n is, it's the number of hops. Okay. So when I say like wide 2-2, What I'm saying is I want it to go 2 hops and it has 2 hops left to go. So when the digipeater receives it, it will decrement that second 2 to a 1 and resend it with a path of wide 2-1. And then another digipeater receiving that will take that 1 off and end up with 0 and say, I can't digipeat this anymore. So it won't send it any farther. Okay. In general, you don't want to use a value for n bigger than 2, except in special cases. And some of the special cases we'll talk about a little bit more, but essentially places that are very sparsely populated with digipeaters and are very rural and are very flat. Those are places where you might want to use 3. Around here, our digipeaters are on top of mountains. They can see a long ways. We don't want to use 3 around here. There was a case a couple of years ago where some guy in Colorado started receiving packets that had a station name of VET-2, which is not a call sign. The packets did not include their call sign. Bad. And they were being sent with a wide 3-3 path. Also bad. And they were being sent every 10 seconds. Also bad. This was not good. This was very, very bad. Tyler Griffiths tracked down the offending station and educated the operator on what he was doing wrong. And that was fixed. So
Count how many fingers he has.
it's not 2. All right. So what does wide NN mean? If you use a path of wide 2-2, when your packet is digipeated, it removes one of those, right? When it gets down to none left, it won't send it anymore. If you want to know what path you should be using, it depends on what you're doing and what you want to accomplish, right? So if you've got a mobile station and you're in a fairly dense area, use wide 1-1, comma, wide 2-1. Now, keep in mind, this is a path, right? So it's going to use up that first one first and then use up that second one. So what's going to happen with wide 1-1 is the first digipeater is going to use that. It's going to say, oh, he wants 1. There's 1 left. I'm going to send it out. And then I'll just be done with that part of the path. The next digipeater will see wide 2-1 and say, oh, he wants it to go 2, but 1's already been used. So I'll decrement the 1 and I'll resend it with a wide 2 path, which won't get digipeated. Not wide 2-0, but just wide 2. I'll show a example of this in a minute. In general, when you're doing this, your packet will only make 2 hops. If you're a mobile station and you're in a sparsely populated area, sparsely populated by APRS stations, you want to use wide 1-1, comma, wide 2-2, which gives you up to 3 hops that are going to happen, right? I didn't talk about the concept of fill-in digipeaters yet, and I have that in the slide here. So let me talk about what that means. This first part of the path, the wide 1-1, is intended to be consumed by a fill-in or local digipeater. And basically, the idea is the main digipeaters may not be able to see my 5-watt HT or my 1-watt Pico APRS device, but a local digipeater, local to where I am, might be able to hear it. And so that is considered a fill-in digipeater. It will pick me up as a low power device and transmit me with higher power that the main digipeaters will pick up. You'll see the diagram or the animation in a minute. Let's say I'm a mobile station where the digis are on mountains, like here. I'm just going to use wide 2-2. I don't need to worry about any fill-in digis, but I still want to get 2 hops out of my packets, right? So I don't have the wide 1-1. So my local, there's a local repeater around or local digipeater that's looking for wide 1-1. He won't touch my packet because I didn't put wide 1-1 in there. I put wide 2-2, so the main digipeaters will see me and they'll do up to 2 hops. This is the only path acceptable in Southern California. Otherwise, your packets might go hundreds of miles farther than you want them to. Okay. Just as an example. All right. What if you're a fixed station? So you've got APRS running at your house, you got a good antenna, and you can see the main digipeaters directly. Use wide 2-1. You're putting out enough power that anybody close to you is going to pick you up direct. The digipeaters will send you one additional hop. That should be typically enough. If you're an airborne station, that is something at 10,000 feet or higher, for example, a balloon, airplane, rocket, something like that, don't put a path at all. You've got enough visual footprint, line of sight, that you don't need to be digipeating anything. You don't need your packets digipeated at all. Just toss your packet out and everybody will hear it, right? Remember, you want to keep your RF traffic relatively local. People 500 miles away don't care what our repeater frequency is or what time our net is. They're probably not going to be checking into it. If I'm publishing an Echolink object, on the other hand, they might be interested in that 500 miles away. So we'll talk about that later. All right, so here's an animation that shows how this works, right? So I start out, I'm a mobile user. I start out with wide 1-1, wide 2-1, I think he was using, right? What did he say he was using? Oh, he's using wide 1-1, wide 2-2. So my home station, acting as a fill-in digipeater, eats the first wide 1-1. And then he resends it to a high-level wide coverage digipeater who receives the wide 2-2 path. And he says, I'm going to decrement the 2 to a 1 and resend it with a wide 2-1. And the other high level digipeaters will see that wide 2-1 and they will resend it one additional time. So I'm getting 3 hops out of it, but because I'm taking advantage of the fill-in digipeater, it's really only going like 2 big hops away. Dan, you had a question?
Have you seen this on like a TCP dump or a Wireshark trace on the actual packets?
No.
I'd love to see.
I think
You have,
We'll need that. I'll
Okay.
give you my email afterwards.
I'd love to see that.
But the objective is to get your packets far enough away that they're useful, but not so far away that they're unuseful, right? So I found that animation and it was so good that I had to find a way to include it. You may also use some kind of special case paths. For example, temp N-N is used for temporary fill-in digipeaters. For example, at field day or something like that, maybe for a specific event, you might use a fill-in digipeater for that. That is only used for that event. And people have to actually put temp 1-1, for example, in their path field for that fill-in repeater digipeater to use it. I've also seen SS, which would be like a state. So here it would be UT 2-2. The objective there is maybe I want to be able to send a packet across the entire state, but not past my state borders. So only Utah digipeaters will digipede packets that have UT whatever in their path, right? And then the other one is link, and that is typically used for long chains of connected digipeaters. There's an event every year called the Appalachian Trail Golden Packet. And what they do is they get people up on mountain peaks along the Appalachian Trail with portable digipeaters using this link path. And the goal is to send a packet from one end of the mountain range all the way along to the other end of the mountain range, and be able to send APRS packets back and forth across this long chain. Yes, Paul?
If you're trying to cover a long chain like that, does it not decrement it?
It does, but you might use something like link 10-10 when you send your packet out. And so it can go through 10 digipeaters, but it's only going to go through 10 digipeaters that are looking for this link path. It won't go through digipeaters that are using wide on their path setup, that are accepting wide aliases. Yeah.
One end of the Appalachian Mountains to the other end,
Yep,
down in Georgia.
Yep.
to Maine.
yep, exactly. And this is a thing that they do every year for fun. And they get up there and they try to do that. And so you'll see guys out there on the mountaintop with a handheld like this with two Yagi antennas on it, one pointing north and one pointing south to hopefully reach the next digipeater that's 50 miles away, right? It's kind of cool. It's kind of a fun thing that they do. There are some websites you can look at to find out how well that works. All right. So why not always use wide 3-3? Then my packet gets everywhere, right? First thing to remember, this is a 1200 baud system on a single frequency nationwide. Okay. The bandwidth is limited. Only one station can transmit at a time. It's kind of like Ethernet in that regard. If I have multiple stations on my Ethernet cable and one is transmitting, the others can't transmit or you'll have a collision. Same thing will happen with APRS. If somebody has keyed up their radio and sending out a packet and another station is also sending a packet at the same time, there will be a collision. Those packets will get messed up and nobody will get them, right? To some extent. There may be some FM locking that happens and one of those packets might get through where the other one does not. The key point is you as the operator sending your packet don't know that a collision has happened. There's no collision detection happening on this. So all you'll know is that your packet didn't get where you wanted it to get to. You may not even know that. Remember, every station is trying to beacon something every 10 minutes. If that packet goes through a digipeater, it's using the frequency twice. Because the digipeater receives it, and then the digipeater retransmits it on the same frequency. Okay. There are some techniques that are used where in a very busy environment, you might set up your digipeaters to receive on a different frequency than the one they transmit on, like a regular repeater does, which can ease up some of that bandwidth restriction. But there are physical limits as to how much information you can push across that single frequency.
So you're listening to your own packet after the first bounce. When
If
that
you
first-
hear it from the digipeater, yes,
Yeah.
you'll hear it come back to you. And in fact, my radio will actually tell me if I have that turned on, which I have it turned off right now. But if I send a packet, if I have the sounds turned on, it'll go beep as it sends the packet. And then when it hears the digipeater send it back out, it'll say beep, I received my own packet. Yay, I got digipeated, right? And if I don't hear that doop, I know the digipeater didn't hear me for some reason. Maybe I'm inside a building or, somewhere where I'm not close to the digipeater. On 2 meters, this thing runs at 1200 baud, right? So it can realistically support about 60 to 90 users that can hear each other directly. More than that, and packets will be getting dropped or lost. And if you just turn your radio on and you're listening, it's really hard to tell how busy it actually is. You can't really tell from listening to the audio what's actually going on. You as receiving packets, you don't know how many packets are being lost and not making it through. You only know about the ones that you get, right? So you can't make a good judgment on how busy the network is right now based on what you can hear. So there's this thing called the Aloha Circle, which is calculated based on your power, height, and gain measurements that are supposed to give you some indication of how far away your packets are supposed to get. And some software has this functionality. This that you see in the picture here, this is the old UI view program, which was one of the early APRS implementations. And it ran on MS-DOS. For some reason, people still use this. It has not been maintained and it will not ever be updated because the guy who wrote it decided that when he died, it would not ever receive another update and the source code would not be given out.
And apparently NORAD uses that.
And-
That's what their displays look like.
and he died. So UIView is dead software. For some unknown reason, people still use this thing. They really should stop using it and use more modern software that does things correctly. But yeah, you see that big circle that's drawn on there. The idea is that's the Aloha circle. It's the stations within that circle are stations that I can reach directly without having to go through a digipeater. Okay. So if you're looking at this and you look at the stations in the circle and you count them, if there's more than 50 or 60, boom, you're probably not, your network is probably overloaded and you're not getting everything that's actually flying out around there. Okay. Use a shorter path, use less power. It's all kind of black magic at that point. Right now, the adoption of APRS is pretty low. I mean, keep in mind, it's been around for what, 40 years, 42 years. So, you know, a lot of the kids these days don't care about APRS because they've got cell phones and they say, oh, I'll just use my cell phone until AT&T has a hiccup and cell phones stop working for a day, right? Which happened recently. All right. So how does it all get online? And how does the wide area stuff and the services that are out there like SMS Gate and Email 2 and those guys, how do they work? So there's a special category of station called an iGate or Internet Gateway that take this on the air RF APRS and put it on the internet. And there's a whole collection structure of interconnected nodes that pass this information back and forth that make up this APRS IS network. Okay. Think of it like linked repeaters in a linked repeater system. Basically, if my iGate receives it, it'll put it out on the internet, and then anybody on the internet can see it. If I send a message to somebody and some other iGate somewhere happens to have heard them on RF, and it sees my packet come in off of the internet and knows that that station is out there on RF, it will send it out on RF to them.
Does that do anything with the hop count?
No. We'll look at some paths in a minute, if we have time. So APRS-IS automatically deduplicates packets. Some packets might get received by more than one iGate, and it will discard any additional ones that have already been seen. So you cannot use data from the APRS-IS to do valid path analysis and see how good your paths are. That doesn't work because the routing, it might be different between two packets. It might, you know, there might be a really good route that's working for APRS-IS that's no good for your local stuff, right? So you got to keep that in mind. But you have to assume that all traffic on APRS-IS either originated or destinates on RF. So you need to be licensed to be using APRS, right? Even though if I'm only doing APRS-IS, I'm like, I don't really need to be licensed because I'm not doing any RF. You have to make the assumption that everything that's on there could be hitting RF at some point or coming from RF. Okay. All right. So lots of cool things you can do with APRS thanks to APRS-IS. SMS Gate, which will SMS Gate has some legal issues, and my understanding is that it's currently offline, kind of. It's offline for general use, but there are special cases where you can make it work. You need to go to the SMS Gate site and look at the notes that they have there to get the full story. Email 2 lets you send and receive email. Some of the stuff requires you to set some things up beforehand before you actually try to do this, because of the fact that these things might end up on RF, and we don't want to be breaking the rules of the FCC when we are talking on RF, right? Whoas can get you information about a call sign. CQ server and AND server are for group messaging. They do this thing every week. It's called APRS Thursday. and it uses AND server. And basically you send a message to AND server with CQ hotg in your message, and it adds you to the hotg group. And then anybody else who sends to AND server with hotg, you'll get a copy of it, whether you're on RF or not. So if somebody on the other side of the planet sends something to hotg, you'll see it, even sitting here in Utah on your handheld, right? WXBot allows you to ask for and retrieve weather information. And then, of course, the SOTA and POTA integrations we talked about briefly already. Other cool things, automagic tuning. And I call it automagic because it's kind of automatic, but it kind of depends on things being set up right. So if you've got a handheld with APRS built into it, and it's sending out a beacon every 10 minutes with your information, one of the things that you can tell your radio to do, depending on your radio, if it has that capability, is to also include in that beacon packet the frequency that your other VFO is on. And so another person who happens to see your packet can say, oh, KD7ZWV, he's on whatever frequency you're on. I think I'm on 146,440 right now. And if your radio is able to do it, you can hit a button on your radio and tune your VFO to that same frequency, which is kind of cool. So then you can have a conversation, right? I don't remember amateur radio is about having conversations, not just about playing with cool technology, although it is about playing with cool technology. There's also a method of operation called voice alert. Now, normally you're going to set your radio up and you don't care to listen to all of the APRS traffic. Let me see if I can get some, if there's any APRS traffic that I'm going to hear inside the building here. We'll see if we hear it. I don't normally want to hear that. And so a lot of people, they would have this running on like the BVFO on their radio, and they would turn the volume down. And that's fine. But keep in mind that if I hear you on APRS, then I should be able to talk to you on simplex, right? So Bob Berninga came up with this idea that he called voice alert, which is basically, instead of turning your volume down, put a CTCSS code of 100 hertz on that memory, and then all the packets you'll send out will have that subtone on them. And if your radio receives that subtone, it will break the squelch and you'll hear it. If it doesn't receive that, it won't, right? So you won't hear all the noise packets coming from digipeaters and everything else. But if somebody happens to have their radio on and configured that way, you'll hear their APRS packet. And then you can key up on that 144.39 frequency and say, hey, APRS voice alert, switch to 144.52 or 140, what is it, 146.52, the national calling frequency, and I'll meet you over there. And then they will have heard that because you sent that with CTCSS and they're decoding CTCSS. So they'll know to switch over there and talk to you, which on simplex, kind of cool. It is kind of magical.
Isn't that why, I mean, do other TNCs have the capability to stay out of transmit when there's a voice transmission going on?
They generally won't transmit if there's a carrier present.
Oh.
So it's carrier detect multiple access. It's like a CDMA network.
Okay, because there are some TNCs are set out to be open squelch all the time.
That is correct. And you will also find some devices like things like the Tiny Track 4 that are unidirectional. They only know how to transmit. They don't know how to receive. And they don't care. They will just transmit when their little timer expires. They'll transmit whether somebody's already transmitting or not. They don't care. So yeah, you have to take that with a grain of salt. So if you do make a voice transmission on the APRS frequency, make it as brief as you can, right? Something like, hey, I hear you. I'm KD7ZWV, QSY to this frequency, and we can talk. And then switch over to that frequency and talk there, right? Okay. Another thing that you can do is this thing called APRS touch tone. So people have built DTMF decoders that they put on regular repeaters or just on a radio somewhere that can hear things. And if I'm at a Hamfest or something, I might have a little diagram of the Hamfest with like a grid drawn on it. And I can use my touch tone on a voice channel to send a code saying where I'm at. And this thing can decode that and put me on a map that APRS people, as an object that APRS people can see. And so I can have, even if my radio doesn't do APRS, I can still have some kind of APRS presence. I've seen them use this at like the Boston Marathon, where they have, it's not like a grid, it's like locations along the course are given a 2-digit DTMF code. And so when you pass a particular place or you're at a particular place as somebody helping out, you punch in your code and it shows up magically on the APRS displays. So that's kind of cool. But keep in mind, the goal of APRS is tactical real-time information. We don't want to necessarily put things out like, oh, last month this was here. I don't care what happened last month. I care what's happening right now. Or, maybe tomorrow there's a camp club meeting here. That's good information for me to know today because I can plan to go to the meeting. After the meeting has happened, I don't really care anymore that meeting happened, right?
Yeah, we can make it feel that.
Well, we can do that anyway, but we don't need APRS to do that. Okay, so demo time. Now we've got about 10 minutes, so we'll see how far we get here. But I'm just going to bring up APRS.5 first. Let me see what I've got. Do I have my browser running? I don't see it. I'm going to go here. There we go. And I'm going to bring this up. Somebody sent a message. Oh, a long time ago, Vern asked, how important are the paths found on the signal link versus the other devices without a control knob? Vern, the idea there is that you can tweak the transmit and receive volume and gain on the signal link manually. The other types of devices like the DigiRig, you just do that in software using the sound control panel on your device. So the advantage of the signal link is I can tweak it dynamically very easily by just reaching over and grabbing it. The disadvantage is I can tweak it dynamically by reaching over and grabbing it, even if I didn't mean to, right? If I bump my signal link and one of those knobs gets turned, suddenly I'm not decoding packets anymore because they're coming in at like 5 times the volume that they should have. So that's the idea there. Okay, well, let me bring this up.
Most times those controls should be almost off.
Yes,
So you don't need the-
they're pretty low usually.
And that's an issue with DigiRig too. Sometimes you can't get it low.
Right? And you might need an attenuator or something in there. Let's see. Or the other thing that you might need to fiddle with is the volume on your device, on your radio, right? That might be an option that you can use. Okay, let me get this over here. So this is APRS.5. And what APRS.5 is a website that was built by this guy named Hesu, who is in Finland, hence the .5. And he said, hey, I can have a computer on APRS-IS receive all of the traffic that comes through that, and I can graphically display it on a map very easily all the time. And it can be worldwide. You can look at it from anywhere and see what's happening wherever you happen to be, because all that data, all that traffic is going worldwide, right? And so what he did was he put together this website to do this. And you will see lots of different things on this map. Couple of the key things that we'll talk about here are, you see this here, this is where we are. And if I click on that, that KD7 ZWB-2 with the little fire station icon is APRS ISCE 32 running on my laptop. The other thing that you can't see very well unless I zoom in, maybe. See how close we can get. So there's a couple other things that you see here. AB0STG5, somebody is running APRS Droid,
That's this phone right here.
and that's running on Chris's phone there. And here you can see, as I pop this up, I can look at information about his communications there. And unfortunately, I'm looking at this with my glasses, which are terrible, but you can see the path here. So you see this APRS 16, that's that destination call sign which identifies the APRS Droid software. Okay. Then you see the path here. It came via TCP/IP and was received by, it was sent with a GAC path and was received by APRS.fly directly on APRS-IS. So it never hit RF, okay? If I look at, what else have I got here?
There's an N7.
My car might be out there too.
There's N7XDL-5. I think I know that guy.
I'm going 4 miles an hour.
Also running APRS Droid. Why are you running so fast, Dan? That is one of the factors of GPS, right? GPS is not 100% precise. So it could be quite wrong, in fact, in certain cases.
Go back to Chris's.
Let me zoom in a little bit more here.
I think Dan's elevation was 4298 and Chris's was 44 something.
Come on, zoom in. Why do you keep?
Yeah.
Oh,
It's
maybe
all
I'm,
month thinners I got prescribed in the last 2 months.
maybe I'm in as far as I can get.
You get a higher elevation. Yeah.
4410. Yeah.
Better blood, less weight.
GPS is notoriously bad on elevation.
Yeah,
So you've got one-
unless you have one that's designed for that.
Well, if you have one that's designed for aviation use.
Let's see if I can take this out the door here and send beacon and see it here. If I'm standing in a Faraday cage, I'll move outside.
Yeah, 400 here.
No, it's in my chart.
No,
So yes, it is in a door.
Apparently my radio doesn't have a GPS fix at the moment, so it might take a minute.
so the one that's picking up, is that you're on your phone?
Yeah, I just put it here. Not the best. I have another microphone I'm going to, that I know works.
Just gonna put it down out there, and we'll see what I use. It might take a minute to get a GPS fix. It's still looking for satellites at the moment. But let's look at other information we can glean here. Let me see if I can zoom this back out and we'll see what else is out here. So when we were doing the thing on Monday, I had this running on RF only at the park. And when I zoomed out, I could actually see a guy over here in South Jordan somewhere. and his icon was a horse. And he was actually horse mobile with his handheld radio. So that was kind of cool.
It was during Pony Express weekend, was
It was not during the Pony Express, no. Zoom out a little bit more. So another thing that you can see here, I actually have a filter. You see all these WX, those are weather stations, and I am annoyed when I see only weather stations, so I'm gonna switch to a filter that doesn't show those. But here's a car out here. And you see when I mouse over him, you see that line that appears? That's showing that his packet, I'm gonna have to zoom out a little bit more so you can actually see the other end of that line. So if we look at his packet, it went to a digipeater up there in, where is that? Farmington? And then down to this guy over here, where it was I-gated. So you can see, or no, this guy down here where it was I-gated. This guy right here with the eye.
I think that Farmington, is a note that's, K7 DAV, I think.
Yeah, I think so.
It's the Davis County Amateur Radio Club / Aries, and it was furnished in part by the Sheriff's Department budget, so.
Oh, nice.
It's designed basically to enable their valley system to reach out.
This car over here, you'll see that he's got like a green line here. This is track or historical information about his station. And because he only beaconed maybe every half hour, I only see one beacon here, and then the next one is over here. And I don't see that he actually followed this road, which I'm pretty sure he probably did. But
Well, it disappears after so long.
it will disappear after a period of time, correct? It will scroll those off. Oh, here's somebody. This KJ7 guy here, he is on his phone. He's also using APRS Droid, but you can see he's actually going out on RF. So he's probably got Moby linked, some kind of TNC hooked up to a radio. So you can actually see that his packet was sent out with wide 1-1, and that was the one that was used, and KF6 RAL2 received it, and then it got gated onto the APRS IS. And then let's see, has mine shown up yet? Zoom in again. It doesn't handle multiple stations in the same place very well. Ah, there I am. So there's my radio sitting out on the sidewalk there. And you can see that mine was gated by KF6 RAL-2 as well. And then if you click on like info here, it'll actually bring up information about that station. And it'll include the last path that it saw. And remember, this is not necessarily the only path. This is just happens to be the path that APRS-5 saw when the packet from my radio got there. But it also shows you some other information about where it's at, things that are nearby, other stations that are maybe nearby my station. There's some other information on here as well. Let's actually pull up one of these weather stations. You click on this guy, you can actually see weather. And it should show us. Let's go. Yeah, let's go back to the to the other display. There's a couple other things I want to show you on here, and then we'll look at something different. If I set this to, and we're back to default. It's the default. Get rid of this. Oh. Get those weather stations back up. So you see some of these are like EW 9449. These are part of the Citizens Weather Observation Program, or CWOP. These are not actually broadcasting on RF. They are strictly being gated into the APRS system. But like this guy, N7, is that BDR? He is on RF, and it shows the temperature is 88, humidity 16%, pressure 1004.3 millibars. Wind is at 332 at calm, gusts of calm. There's been no rain in the last 24 hours. And so if you have a weather station, you can send that kind of information out too. A lot of times you'll see repeaters put on telemetry information, like what their battery situation looks like, what their operating temperature is, and things like that. So that's kind of cool. The other thing I wanted to show you was, if I hit WinLink gateways on here, I actually get the WinLink system publishes these objects. So when somebody has a machine that checks in as an RMS to the CMS will actually post something on APRS saying where they are. And it has theoretically useful information like the frequency and the protocol. So this is a VAR FM gateway on 145.050. So theoretically, if I know that that's close to me, I will tune my radio to that and use VARA, and I can send my WinLink stuff to him. You'll also see some other ones as well. Other of these special gateways. Yeah.
Is there a filter for APRS on LoRa?
I don't have one, but you can create your own custom filters.
Well, I'm not sure that he's importing LoRa data into his system anyway.
If it's getting into APRS, then he'll see it. So that's another thing. There's this thing called LoRa, which is a low power mesh type network, and people are pushing APRS packets over that as well. So I know Paul's been experimenting with that a little bit, but yeah, so that's the basics on APRS.5. And I encourage you to go there and create an account, check it out, play around with it, see what kinds of things you can do with it. It's really pretty slick. And I will bring up this real quick. This is APRS ISCE, and this is what I was running at the park on Monday. Now I have this hooked up to APRS IS, not to a radio. So it's seeing a lot of things that you would not normally see if you were just on the radio. Because remember, if I'm on the radio, I'm only going to pick up things that are on RF or that have been gated to RF by an iGate. One thing that I like about this is it actually handles multiple stations in the same location a little better. And so if I click on this pile up here at the fire station, I can see all of the stations that are here and actually be able to pick the one that I'm interested in.
So how did you control the radius or the diameter of this circle?
So when you connect to APRS IS, you can actually specify a filter that says things like only show me things within some number of kilometers of me. And then it won't bother to send you ones that are outside of that.
So is that how you did it at the safety fair?
I was only on RF at the safety fair.
Oh, only on.
So I was only picking up direct and digipeated packets from at the safety fair.
But I saw a circle on your laptop.
So this circle is just an aspect of the program. It doesn't really tell you anything useful. I don't even know why it's on there.
So you just zoom for less. So you know.
Yeah, I could zoom in, so I can zoom closer to where we are. And this APRS will use OpenStreetMap data to draw the map. Who's this guy parked out way over here? Maybe 0 STG9.
Yeah, that's the radio on the car.
So that's in your car. So I can see him because he's being gated onto the network. Now, one of the things that this particular software allows you to do is assign nicknames to stations. And I did that during the front runner ride, even though we only had 2 stations that were doing APRS. Mine and I think Ragnar sent like 2 packets for the entire course of the ride. But the idea there being that as a net control for a racer, a ride or something like that, if I know that a particular station is serving a particular role like Moto 1 or SAG 3 or whatever, I can assign a nickname to him. And instead of showing up with the call sign, he'll show up with that nickname on my map, which is very useful.
So the other station doesn't see the nickname you assigned.
No, they
That's
won't,
good.
they don't see that. Yeah, because I could name them whatever I want, right? I could, oh, Ryan, yeah, I don't like him, so I'm gonna put Jerk on his alias there. Yeah, Jerk 1. And yeah, so I mean, you can do that, but that's kind of the idea there. Some APRS software has that functionality capability, other software does not. But yeah, let me get this back off the screen. And I'll go rescue my radio real quick.
Well, at least if it's still we can track it.
Right?
So let's go back to the presentation. I'm not going to try to show you the screen of the Kenwood because it's really tiny and you guys are a long ways away. So if you want to look at it after the meeting, I'll keep it online for a while. But there's a ton of information out there. Here's just a few links that will give you some additional things to look into. APRS.org is the official website for APRS. APRS Tactical talks about using tactical call signs and more tactical type of information. This page had a good description of how the pathing works. This is a link to the MobiLink D product where you can go buy it. It's only like $70. And that works with pretty much any radio. This is a link to the Pico APRS device, which I think last time I looked at it, it was like $800. So if you want to buy one, just give me the $800 and I will build you something that sort of has that functionality for much less. There's a link to the Appalachian Trail Golden Packet. There's a link to the APRS IS site that where you can see the status of the system and that kind of stuff, and a link to APRS-5. So those are all on this links page. And whoop, did I kill it? I killed it. But I get all the way back to the beginning. We go all the way to the end. Here we go. Probably a way to do this much faster, but I don't know what it is. So any other questions or comments? Let me have it.
What are we gonna do next month?
Next month, I want people to bring, if you have a radio that has APRS built into it, bring it. We will figure out how to configure it if you've never done so. And we will play around with that a little bit. if you have a Signal Link or a DigiRig and a PC and you want to try some PC software, bring that. Just like we did when we were doing the WinLink, we'll get the stuff installed, get it configured, and figure out how to make it work. So those are kind of our goals for the next meeting. We may or may not accomplish all of those goals, depending on how many people show up. Oh, look, I just sent a packet. Nobody received it because I'm back inside the building, but oh well. You didn't hear the bedoop when it would have been
It would have
received.
acknowledged it, so.
If the digipeater had sent it out, I would have heard that and it would have beeped at me to say that. But it did not because I'm sitting in here. But yeah, that's it.
When do we need to bring a computer?
If you bring a computer next month
Computer and a radio.
and a radio and your Signal Link or DigiRig or whatever other TNC type device you have. Or if you've got a radio that has APRS built in, like your Kenwood, your Yaesu FT2, I think, has APRS in it. If you've got an Anytone 878, that will do it. There's lots of different options out there. So if your radio said APRS on the box and you never did anything with it and you want to figure out how to make it do it, come next time. Not next week. This will be in a month, second Thursday of September. And
Yeah.
September.
We'll see you in September.
Yeah. Paul,
Is there a 70 centimeter frequency on which APRS is?
there is not a standardized 70 centimeter frequency, but people do pick a unused frequency on 70 centimeters and use that for specific applications. I've looked at the simplex frequency map for Utah, and it doesn't say anything specific for APRS on 70 centimeters. Other places might. It just depends.
I personally look for a local repeater. Between my APRS.
That's always welcome.
You can do that. And there's actually a protocol called Mike E. Where when you're talking on a voice repeater, for example, if your radio is configured for this, when you unkey, it will send a very short coded burst of packet data that is in APRS format, but it's not human readable. It's like really tightly compressed and in what they call Mike E format. And it puts a pin in the map, right? So if the repeater is configured to decode that and forward that on to the APRS system, you will appear on APRS from that. Nobody does that anymore. Pretty much nobody does that anymore. You'll still find people using Mike E protocol on portable devices because the packets are much shorter and they take up less bandwidth on the frequency. So you might see Mike E packets out there that are getting decoded, but I don't know of anybody who's doing actual Mike E on regular repeaters. You may find that for a special event or something like that, kind of like the APRS touch tone thing. It would be very localized to that type of event. Other questions, comments?
Thanks, Jan.
If not, I will stop the recording